Hi, everybody. So I'm absolutely thrilled about this upcoming panel. So Jimmy Jones is the head of security at Zariot, and they are an eSIM provider. And he's going to talk about how he has delved into and figured out how to enable encrypted data exchange through the eSIM to start empowering people to take control of their data. And then once he's done, we're going to have a quick Q&A about that. So let's go. Let's make it happen.
Thank you. Okay, so my name's Jimmy Jones. I work for Zariot, and you normally only find me in the IoT group. I don't normally venture out into areas outside that. But 2 weeks ago, there was a presentation, a cross-group presentation that MEF did to the IoT group, and I heard a presentation that really resonated with me because it echoed what a presentation I'd actually made at Mobile World Congress in March. We were at Mobile World Congress, we were talking about eSIM. It was mainly about eSIM, to be honest. But one of the slides that we put up there was that for IoT to be successful, it has to be trusted. And the only way it can be trusted is to be secure, and we have to have legislation to drive people towards that. So that was all part of what I was talking about. And then I suddenly heard a presentation, and I saw this slide, and it really brought me back into the room. I was, like most of us, I was probably doing my emails at the same time as I was listening to the presentation. But it was so close to what I'd been talking about that it dragged me back. So just a quick one on Zariot. Zariot is a cellular IoT provider with a particular focus on security, and we won an award at GSMA. My marketing team makes me put that on every slide. But the important part of this presentation is we have the ability to be able to create profiles and applets and file systems on eSIMs, and we also have a belief in the ecosystem. So what we want to do is we want to address 6 major areas. And when I came to the company about a year ago, I wanted to add some tangible benefits. And the first thing I wanted to do was put end-to-end encryption on there. So end-to-end encryption is available via the excellent GSMA Safe program, but there's some elements of that I felt we could lower the barrier of adoption, and there were some elements I'd like to have changed. So I was basically just looking for an end-to-end encryption party to work with, because they would help me address data integrity, security, and privacy. And I came across a company in America called the At Company. So the At Company were recommended to me as being a very innovative company. And I started talking to them, and to be honest, I was more interested in the security and the data integrity. To me, that was key for my IoT solution. The privacy, obviously I wanted it and I understood it, but I saw it as basically GDPR overhead. I was seeing it as there's lots of devices all getting little bits of information. If you put that in a big data pool and you use AI and ML, does it suddenly come under GDPR? So I was coming from that angle. And it was only when I started to get educated by the At Company that I started to see the wider picture, and I started to understand what you guys talk about. They were talking about the problems we have today. I knew them, we all know them, but I just didn't think there was anything you could really do about it. I just thought that was the way that life is. What can we really do? And then they started to tell me that they actually had already done something about it. So what they were looking to do is they were looking to put the power back into the consumer. So they have a tagline, flip the internet. So essentially take the data from the internet, from the guys who are holding it there on the applications, and giving it back to the user, which is a great story, and it resonates quite well, because we could see it actually fitting very closely into IoT, because we all own IoT devices and we all own our own identity as well, obviously. So they were looking to do that via their app platform. So I'll try and explain it as quickly as I can and try not to lose everybody because I'm poor at explaining things, but you have a unique identity with the At Company. So if you go onto their website, atsign.com, atsign.com, you can get your own @sign. It's free, unless you want sort of Kim Kardashian or Google or something like that. They'll charge you for those. But it's a free identifier. That identifier is used to identify that particular device with IoT, with us, or the person. So with the IoT device, what we do is we take that identifier, we put in a key, and then we have an exchange when the device goes live. We replace the symmetric key with a private key, and it's only ever held on that device. It's created on that device, it's held on that device, it's not held in a repository anywhere else. So it identifies that device exactly. We hash it with the IMEI if you want to know, so you know you can't take the SIM out or anything like that. With the @sign, if you build one yourself, you have to keep it in a safe place because you want to be able to use it on your iPhone or your iPad or your laptop or whatever. So the interesting thing here is that allows you full control because that device and that user is the only person who knows their key. So any decisions they make to share data is made by them. The platform, I'm going to dumb it down a little bit now, is they use something called a secondary server, which is a little bit like a proxy. So every device is talking to this secondary server, and that's owned by the service provider. So, for instance, if I wanted to create a, let's think of something, an industrial site, a closed industrial site, I could have all my IoT devices talking to my secondary server owned by Jimmy Jones Factory, and all of my users would be able to talk to them as well. Each of those devices could be set to share to anything. So I could share data with Michael, let him see how the manufacturing device is running, the oil pressure and things like that. But I could just as easily share something else with how many devices they've actually created. So it's full control. And everything is end-to-end encrypted, device to device. So there's no man in the middle. The first question I'm sure you're all going to ask is, what if I hack the secondary server? Secondary server is a 6 megabit binary, that's it. And it's, unless you manage to have hacked both ends keys, you can't actually see anything in the middle anyway. And it's not blockchain. I've got nothing against blockchain, by the way. We've got eSIMs being developed that actually are looking to hold the blockchain certificates as well, that hopefully they'll be out Q3. So we're looking at that and we see that as valuable, but having something different I think is interesting as well. Okay. So what did we do? So what we did is we wanted to make sure this was real. So there's apps out there that you can use on the company's platform, and you can get them off the App Store if you go on there. But we wanted to make something tangible, something where we could show the solution working. And that's exactly what we did. And the device in the corner, we'll just see a video of it in a moment. That was the core of our demo at Mobile World Congress in Barcelona. The extra area, that might interest you is the devices are talking to the secondary server, so they're only ever talking outbound. So you've got full control, but you're only communicating in one direction. What that means is you don't have to have static IP addresses. So anybody who's at IoT, static IP addresses are a bit of a pain to administer. But also those devices don't have to listen on any ports. So it's fully secure. If I look for that device, it's not listening on any ports, it only talks outbound. So I won't see an SSH open, I won't see a telnet open, I won't see anything open. So that really helps us. And it eliminates some of the need for VPN tunnels, which again is difficult for us. So what we're going to see is the demo in action. Right at the end is a privacy part. I think it's probably the most interesting for you, but this is from Mobile World, so there's a little bit at the beginning for about eSIM. The device is a heart rate and oxygen monitor, and that's going to produce data, and we're going to share it with different people in different ways. And then we're also going to see that the device has got a problem, maybe it's on a bicycle or something like that, and we're going to show the location for the tech fix-it man to come and help the guy fix the problem. Yeah, so let's just crack on, I think. Okay, so this is the device. Essentially, it's just a Raspberry Pi with an LTE hat on top, and then a little 1.5-inch display on top of that. The oxygen and heart rate is taken by this element. Basically uses light to check your pulse rate, And you'll see the guy puts his finger on there, and you'll suddenly see his heart rate get captured. So now what we're doing is we're capturing that information, we're using it to upload that information to the applications that are attached, and there's going to be two applications that are attached. There's going to be the doctor, and there's also going to be the fitness instructor. So obviously with the doctor, then we want them to be able to see everything. We want them to understand everything that's going on. So we provide both the heart rate and the oxygen monitor. The interesting thing here is with the privacy is in America you can change your doctor, maybe they've for insurance reasons or something like that. If you took the Dr. A off and shared the information with Dr. B, then because you hold all that information and you're just making it available, then your records will be only seen on the second doctor. As you can see, this is the fitness instructor, and the data there is being shared incrementally, so they don't get the oxygen. That's under the control of whoever owns the device. And that's really interesting because if you think about it, there's some options away from this. I'll just pause that a second because I like this part. If you imagine the case where there's a camera in your house, you may want to share that camera's data only with your phone. Maybe that camera points on your child's bedroom or something like that. So you only ever want that to go to your device. It's point-to-point encryption. So that would be connected directly to your device. No one else could see it. We couldn't see it, the app company couldn't see it, whoever owns the application couldn't see it. You could still open that up for hardware to be upgraded. You need to be able to do that for security reasons as well. And you can provide access to that fully securely via, it sort of uses a reverse SSH. There's a video of it on our website if you want to watch it. You can allow the administrator to look at that. Now, if you suddenly had a problem with the video, you can temporarily allow the maintenance engineer to see it, and then you can turn it back off again. So you've got full control. What we're about to see now is a similar situation. Here, the device owner is I think he's in Wales or Scotland. He's going to release his information to Mr. Tech Fix-It. So you can see at the moment, Athletic Andy, he's just looked at his device and he hasn't released his location. So we're going to see Mr. Tech Fix-It. He's going to look and he's not going to have Andy's location. Andy's then going to go onto his device and he's going to open it up and he's in Snowdonia. Okay, so he's just slid that to the other location. Now he's opening it up to Mr. Tech Fix-It. Mr. Tech Fix-It, now when he looks, knows where he is, and he can go to the campsite or wherever that is and fix whatever it was. So that's already available. We've done it on IoT. This is using this application actually is something called Wavy, or Wavy, I'm not sure how you say it. But there's a few applications that are already on the app company's Play Store that you can get. So that's where the real privacy comes. It really shows it. But the interesting thing is when we talk about IoT Safe is, like I say, it's fantastic. But actually, it's only to the edge of the cloud. So you're actually encrypting from your device to AWS or Azure or Google. With this, what you're actually doing, because you're talking through the secondary server and the secondary server's there, then your encryption is actually from your device to the device in the palm of your hand. So that's true end-to-end encryption. And that could be exactly the same if I was talking person to person or sharing data person to person. It's from me to them. There's nothing in the middle, no data to be shared unless I want to share it, which is great for my customers as well because it removes the GDPR overhead because you have to implicitly share it. So they've agreed. I'd like to say this was more about Zariot than the app company. It's not. We're just an enabler. And I think it's really interesting that, listening to Michael's presentation 2 weeks ago, that there's no way I know how to fix that algorithm, by the way. But I think what we can do is, if we work together, we're able to show that if people understand, I was educated, if people understand what the problems are, I think we can all come together and try and help them deliver that. And I think that's where the ecosystem with things like MEF is really important, because I would have never ever attended this event if I'm honest. I would have just seen, I've got too many other emails to write. But I think moving forward, privacy is going to be a concern for all of us. So we just have to make that happen. And I think the Act Company and hopefully a Zariot SIM will be part of your solutions for that. That's all I've got to say. I hope that was okay.
All right, so we have a few moments for some Q&A, and I also want to provide some clarity as well. So in our discussion, partly what you were talking about, the man-in-the-middle software in the server in there, is there a data store in there, or is it just purely passing data back and forth?
It's just purely passing data. So it works a little bit like a proxy. And like I say, you could give that was my massive concern, is what is that secondary server doing, where is it, and what does it hold? Like I said, it's just a binary, so it's difficult to hack just for that. But unless it only holds the public keys, so it has no idea what the private keys are. So unless you've hacked element A and element B, then there's no point hacking the secondary server. So you can't see anything because those two elements are the elements communicate.
And it's interesting hearing your language too, because given your existence is primarily security, so you're obviously concerned about encryption and hacking and all of that. And unfortunately, he was in Barcelona yesterday for a conference, and we pulled him in to say, you got to fly in for this to give us a keynote. So thank you for that, by the way.
No problem.
And but because of that, you missed Mitchell's conversation yesterday from MyDex, talking about that centralization personal data store and how that can be that intermediary layer. So your example is showing how you can do the end-to-end pass-through of, say, the video feeds or the data. But that interim, another node within that interim network could be my personal data store that Alan was talking about. So it would be a way for people to be able to collect and start amassing their data and that history. So that's one kind of point I wanted to point out.
You've got absolutely your control, because that private key, which is central to be able to release that data, only exists in your device, which obviously you could use the same key across your multiple devices. But for the IoT, you've bought the IoT.
Yep.
You've bought whatever it is. When we encrypt, we essentially hash against the IMEI, so the physical identifier. So you can't move it from anything. You can't take the SIM out and put it somewhere else. Right. It's nailed down. You bought it. It's your information. You've got full control. You can, depending on the complexity of the device, obviously, you can set the application to release whatever data you want.
Right. On that note too, I want us to reflect back to our conversation yesterday with the automotive speakers, and one of the questions I raised is this whole idea of, wait a minute, the car's producing a lot of data. Should that not be an economic asset for me? And value being whether either remunerated in money or in some other value exchange. And I think this raises a really interesting opportunity, because in yesterday's panel, we were talking about, well, the car company's getting that data, but if we were to drop your eSIM solution onto the car, the company could take the data, but it's encrypted. They couldn't do anything with it. And so therefore, this would actually open up that ability for us to have a business model around me being in control of that data coming out of my car.
Yeah, exactly. And if you look at it as, I always look at it as a device, but if you look at it as the personal identifier, the personal @sign, and you can get one of these if you go to their website. If I took that @sign and I use that as the key for my car, then that car just becomes the same as my mobile phone, the same as my iPad or my laptop.
It's another node in my life.
It's another node that's being identified by that unique @sign, and I have control of that. So I could have as many devices as I wanted.
Yes.
And the car's a big device, but I can have as many elements as I want connected to that.
Well, yeah, and to your point, car's got many nodes in it itself, so there might be some micro nodes within the car, but we could go.
Yeah, and you don't have to keep the keys on a SIM. You can put it on a TPM or something like that. You don't necessarily have to use it on. I prefer if you use it on cellular, obviously, but you don't have to. You could use any secure element to save it.
So there's another point that you brought up that I think is important for us to touch on. Is you made this statement: this is not on a blockchain. And I think that's really important. And so we didn't really talk about blockchain yesterday, but a lot of the self-sovereign identity methods and implementations that you'll be hearing later today, many do leverage or use what's called the blockchain. There are other protocols, for example, like the carry protocol, which unfortunately John Berner didn't get to talk to about yesterday much, but that's an example of being able to do the self-sovereign identity without the blockchain. But stepping even a step further from that, the whole idea is to be able to, for me as an individual, to decentralize the management of my data. And I'm trying to put into context yesterday's conversation for today, so bear with me. So if you remember, Andrew Budd yesterday in his keynote, opening keynote, had said there's three kind of ways we're managing identity. There is the centralized method, there is the federalized method, and there is the decentralized method. And so what Jimmy just shared with us, that we can also now not only manage our identities in a decentralized method, but we can manage all of our personal data in a decentralized method, because just like Alan and everyone started talking about yesterday, as well as Andrew, identity is just yet another attribute within my pool of my data, and I think you just demonstrated that to us. And so the key is we can manage that decentralization without the blockchain ledger and all of those, and I think that's a very important point.
Yeah, I think there's different solutions for everything. IoT is so vast. I'll keep coming back to that, but IoT is so vast that there's not one right decision. Blockchain, like I said, we're working with a blockchain company, but what's important is being able to give that choice, because there's going to be times when you don't want to lock things down. There's going to be times when IoT safe is the right option. There's going to be times when the app company is the right option. There's going to be times where blockchain is the right option. There's so many things happening at the moment that affect us and that are different, and we're all learning. We need to be able to have access to all of them. So I think what companies like Zariot can do is take those initiatives and take those innovations and make them available. And that's, I think, where we have to be strong, because everything's an ecosystem. Moving forward, everything is going to be collaboration and cooperation. Everything's too big for one company to try and do, and telco is really bad for that. Telco is normally a solution looking for a problem. We don't want to do that anymore. You need to. The first question to any of our customers on our side is, if technology was no object, what would you want? We don't fix all of that, but if we can start from at least trying, and as an ecosystem work towards it, I think it's the way forward.
Well, and let's tell you, and Andrew Budd gave us that example this morning, through the use of the MEF working groups, and just how you and I got connected. For example, I'm chairing the Personal Data and Identity working group. You're part of the IoT working group, and we're bringing these pieces together in a way to be able to make this happen today. There's one other point that I want to bring up that I think is really important. So yesterday we were talking a lot about this idea of a verified credential, and that verified credential being a unique cryptographic ID that I can be in control of and maintain myself. And that is a very specific infrastructure defined terminology, which is defined by the WC3 under a concept called the decentralized identifier. You can go all out and see that. But you then just brought up another idea called the @ sign, or the @ string, which is nothing more than just an identifier that is very similar to the verified credential. So they're similar but different, and they could be mapped, no? Or how?
Yeah, exactly. So it's a unique identifier that uses a separate private key. So it's just the way that it's run to you. It means you could even, if you lose the key, for instance, you can refresh the key. But I think that's key. We need to be. The one thing in life is you have your identity. We've all got our own names, and we respond to that. We don't hand out our PIN number to our bank. We don't use that as our identifier. We use our names. I think that's what our identity really comes down to. That privacy. You need your identity. You need to protect your identity, and you need to have the ability to keep things that you want private, but share things that you're not worried about, because you still need the world to spin round. You still need companies to give you services and whatever else they do. So you want to be able to share what you want to be able to share, but exactly the same way as when we go out for a night out and I go and share what I want about you. I don't share my darkest secrets. I haven't got any dark secrets actually, but I don't share the dark secrets. I share what I want to share with you, and as I trust you more, I share more and more. That's exactly what the outcome.
Well, I think, again, if we stemming off what we learned yesterday too, when we think about what is an individual can be a human, it can be an enterprise, it can be an organization, but it can also be my things. because an individual gets its own identity, and me as the owner of those things, and then all can roll up into me. And I think those are really important concepts that I think we're learning today. All right, we only have about 3-4 minutes left, right? So let's get a couple questions from the audience. Yeah.
This application system entails that the IoT device has a SIM in it, right?
An eSIM, yeah.
Or an eSIM, yes, which is not the case for most IoT devices because they're kind of small chip and they haven't got enough energy to run complex cryptographics or encryption. So the application will be limited only for those devices that economically they can afford a SIM slot or an eSIM that is soldered onto it. But last time I saw the numbers in percentages, it's relatively low. There's lots of IoT devices don't have the possibility to hold a SIM.
Yeah, sure. So really, really good question. First of all, you don't need to put the @sign on a cellular device. You can put it on any device. So you'd probably need a TPM, if I'm honest, or some other secure element, which again wouldn't fix your problem. What we see is that you look at elements as you describe, a lot of those tend to go to a router. So if you think about a LoRa network, you'll have lots of little devices, but there'll be a router nearby. They'll connect into that. That router does have the ability to have a SIM in it, and you can start to create the security there. It's never going to be a fix-all, though the app company's application, they're dropping it down and down, making it lower and lower CPU needs, but that's always going to be a problem. You're right. But I think what we need to move away from is what you've described there is like a sensor, machine to machine. And there's always going to be billions of those. And when you see those huge numbers, yes, they're talking about those. But the other elements that are becoming connected, they have got that power. So the connected fridge is one that everybody abuses IoT with. That has got enough power to do it. So is the kettle. So is and moving forward, when you look at future generations of telco, if you start to bring the speeds up, I'm going 6G now, everybody will hate me now, but if you start to move to those sort of speeds, what you're actually doing then is you're removing the need for local CPU, and you're moving it because the speeds are so quick for the network that you can host that locally and you get the mobile edge compute and stuff like that. So moving forward, hopefully that will be taken away, but yeah, it only scales to a certain level, but I think that level is one, coming down, but two, is opening up to a larger set of devices than you'd actually think.
Okay, thank you.
Perfect. Any other questions? No? Yep. Gilbert.
Hi, you mentioned at the start of your talk that you wanted to see regulations to help build trust in this area.
Yeah.
Do you think we're covered already by things like GDPR? Is that mission accomplished, or what are you looking to see specifically in the IoT space?
So in the IoT space, we have the Radio Equipment Directive in the EU. We have legislation going through in the UK and Singapore and Australia and the US. The good thing is they all essentially boil back to something called ETSI 303-645, one document. That made me sound really boring. But they all boil back to that particular document. And that's the sort of legislation we were looking at because we're very focused on that. So when I presented at the GSMA, that was where I was talking about. GDPR, I've always seen it as a bit of an overhead, a bit of a problem for business. And that's how with my telco blinkers, which live there most of the time, it's always, how do we make sure we're not going to come under that? But it was only when I started to speak to the app company and I started to understand, actually, it's my privacy. Why am I worried about enterprises being fined when actually I'm allowing my privacy to be abused? So yeah, I was talking about a different bit of legislation, but yeah, you caught me out there. Well done. Thanks.
Fantastic. And what other a few of the other problems that you see? So regulations one, you mentioned that we need to come together to solve some of these problems. Can you think about some of the other ones?
Yeah, I mean, it's weird. If you go on to any, if you look at any surveys that are done on IoT, you can see the list of barriers to adoption. They're always the same. There's the technology issue. Nobody knows what they want to do. And then 91%, and I've took that percentage off of Microsoft's survey, are worried about security. And that's absolutely right. If you're not secure, then you can't trust the IoT, then it's never going to be deployed in the numbers we want to actually make a difference. But when you look at, and this is from Gartner, this one, the spend on security is 3 or 4%. So that's, how did we get from 91% to 3 or 4%? Where's that difference? And I think that's coming together at the moment. And I think legislation is one way, but I think actually we're going to push the security issue, because as you're interacting with IoT more and more, your digital experiences in your real life are actually merging. They're becoming the same. You've got a great statistic, 18 seconds by 2025 that we work in IoT. So every element of your life is going to be connected. So that means that your physical and your online security are merging as well. At some point in time, people are going to realise that, and selling IoT with bad security is going to be like selling a car without seatbelts. It's just going to be ethically unacceptable. And I think that might be the real driver. The legislation will crowbar people, but you need a carrot and a stick, and I think we're the carrot.
Fantastic. Well, thank you very much. Appreciate it. Thanks.